All right, so here's my first example using the product rule. So I'll keep the product rule written over here. It says that if you have two products that are being multiplied together, you can take the derivative of the first, multiply by the second, and then add the derivative of the second times the first. Sometimes you'll see that switched around, but that's okay because addition is commutative here. So let's go ahead and look at the first example here. We want to know what is h prime of x. So if I'm using the product rule, would I have to use the product rule? Is a good question. Not if I multiplied this out. I could FOIL that out and then go term by term. But just to get the first example here, we would say the derivative of that is the derivative of the first, which is 3 minus 4x, times the second, 5 plus 4x, plus the derivative of the second, so I'm going to take the derivative of this and move it down here, which would be 4 times the first, 3x minus 2x squared. So as of right now, you've taken the derivative, all right? But usually we would clean this up a little bit, simplify it in case we needed to solve it for 0 later on when you're using the first properties of the first derivative. So I'm going to go ahead and multiply these first two terms out, and we'll step it all the way. So 3 times 5 is 15. Outers give me 3 times 4x, which is 12x. The inners give me negative 4x times 5, which is negative 20x. Make that x a little better. And last times last, negative 4x times negative positive 4x would be negative 16x squared. Then I can distribute this. So I'd have 12x plus 12x. 4 times minus 2x squared would give us a 4x squared, minus 4x squared. So now I could go through and simplify by combining my like terms. So I'll start with my, let's see, I'll start with my x squared terms. Negative 16 and negative 8 ends up being a negative 24x squared. Then we will go ahead and, let's see, combine our x terms. I'll double underline those. So negative 20x plus 12x, that ends up being minus 8x. And let's see, oops, I forgot one, didn't I? That's okay. This is also an x term. So 12 and 12, that gives us 24. And 24 minus 20 is just a 4x. And then last but not least, constant terms. So that would be a plus 15. So when we take the derivative of this, this is our final answer, simplified. All right, so here's a second example. Notice there's no foiling. I can't multiply those things together. So I have to treat this. A lot of times I have students just put a little multiplication sign in there to remind them that they're multiplying and therefore going to have to use this over here. So let's go and take the derivative of the first. All right, so this will be my first, this will be my second. The derivative of the first ends up being 6x times the second plus the derivative of the second, which is sine of x. So we know the derivative of the sine of x is the cosine of x. And then I would have just to multiply by the first, which is 3x squared. So that's why I left this little space here, just because I knew it was going to simplify that way. So there you have it. That is a kind of a one-step problem. 6x times sine x plus 3x squared times cosine x. And that is our derivative. All right, so starting with the third example, I have a term here and a term here. So I've got to go through and differentiate this term by term. So the first thing I would do is, and notice I already have my multiplication in here. So the derivative of the first is 2. The derivative of 2x is 2 times the second, which is cosine of x. Then I'd have to take the derivative of the second. So the derivative of cosine is actually negative sine. And then I'm going to multiply by the first, which is a 2x. Then I'm going to take the second term here. So minus the derivative of the first is a 0 times the second. 0 sine x, easy enough, right? Times the derivative of the second, which is cosine x times the first. But notice this has parentheses around it. So this has to have parentheses around it down here, right? I'm subtracting the derivative. So what happens is kind of neat. I have negative 2x, I'm sorry, I have 2 cosine x, and that's going to cancel with negative 2 cosine x. And 0, that just goes to 0, okay? So the last thing that's remaining is negative sine of x times 2x. But we'd probably clean that up and say that is equivalent to negative 2x sine x. So that would give you your final answer for what is the derivative of this expression up here.